Hello and welcome to the TRILUX Academy. My name's Helen Looms.
And my name's Jamie Yates, and today we will be discussing maintenance factors, challenging the default of 0.8. Quite a challenging subject, so we're going to dive in now and go straight to the first sort of quick recap of what maintenance factors are. Well, they're used in obviously lighting designs to determine what the correct level of light is going to be at the end of your project. These are made up of four key elements, that being the lamp lumen maintenance factor, the lamp survival factor, the luminaire maintenance factor, and the room surface maintenance factor.
So let's just try and explain what they all are to start off with.
Yeah. So the first one, lamp lumen maintenance factor.
This is the amount of light you want, or flux as we often call it, that you want to remain at the end of the project at a given point in time.
Next one is lamp survival factor.
This is the amount of luminaires that have not failed at a given point in time.
And then we have the luminaire maintenance factor.
Now this is the more complicated element where you have to try and predict how much dirt or dust might land on the luminaire and affect its light output over this period of time that we're talking about.
Yeah, the guesswork is actually taken out of this to a fair degree because there are documents and tables which allow you to work out, given the project detail, what it is
yes,
that you're
we make
at.
a lot of assumptions, so we use that within the calculation. That's not to say that's definitely what will
Indeed.
happen, but it helps us have a base unit that everybody can use.
And then finally the room surface maintenance factor.
And this is down to the client. How often are they going to clean, decorate or maintain the space within which we're lighting?
Indeed. So you'll notice that the common theme amongst these statements is at any given point in time. So you need to work out the first part of the project is the operational hours. So for example, office hours, 10 to 14 hours a day, maybe 5 or 7 days a week. Industrial, 12 to 24 hours a day, and again that could be 5, 6, 7 days a week. Retail, 10 to 16 hours a day, maybe 6 or 7 days a week.
And this is the kind of information we have to ask the client about.
Yes, absolutely. So obviously a bit more difficult if it's a Cat A fit out, which will still be office, but
you can make more assumptions.
Exactly.
Yes.
So once you've determined the operational hours, you then need to determine on the project lifetime the long-term life element. Now, this we think can come under 5 different categories. The first one being luminaire life. So you could potentially be looking at, for a commercial luminaire, 50,000 hours, and that tends to be a common theme for how you look at a project.
This is what most people are going to consider.
Yeah.
How much life can they get out of the luminaire?
Exactly. However, there may be something or a number of ways to look at this that are more applicable to the client. And again, this is where you need that discussion with the client to find out what is actually the driving factor behind the maintenance factor. So the other elements you can look at is building life cycle. So if you've got a building, say like the Millennium Dome, which was designed for a 25-year lifetime, so therefore you could, if the building has got a finite lifetime program, you could set the maintenance factor to be the lifetime of that particular building.
Yes.
Not many buildings have a short lifetime. Most of them are designed to exist infinitum.
Or in a retail environment, you might
Exactly.
know that they're going to refurbish after 5 years, they want to refresh.
Yep.
So there's no point in designing your lighting to last for 10 years when it's all going to be changed.
So maybe
after
actually it's
5.
not building life cycle, it's the installation life cycle.
Yes.
Yep. The next one is client policy. So some particular customers or clients may want to look at projects over a fixed period of time that is consistent across the board for any other technology that they may be looking at. So some particular clients that I know of, they will want to look at something over 10 years, and that's the fixed term for any technology that they look at, is they want to look at it over a 10-year life cycle program.
Okay.
The next one, and this is quite a hot topic because it is becoming more and more prevalent, is lease length. So let's say, for example, you had a retail application that maybe would normally go to sort of 6 or 7 years before the next refurbishment, but actually the lease is only 5 years in length, and they don't necessarily know that they're going to renew it. So therefore, you may look at the project here based on the lease length,
Yes.
which may be long or it may be short. And then the final one could even be the payback period. So if energy efficiency studies have been carried out and there are particular payback periods that have been applied to a project, they may just want to look at the lighting design element on the same period that the payback period is. This is a little bit unusual, and obviously it may go anywhere between sort of 2 years, 5 years, maybe even 10 years if the payback period is very long.
And this makes sense if you've got a fairly short payback period and that is what your decisions are based upon. You don't want to be overlighting because the lighting could go on for another 5 years after that period.
Yeah. So as you can see, there are a number of different factors that you can use to take into account the long-term life cycle of the project, and this is actually quite critical. Don't just assume that it's the lifetime of the luminaire that defines the project life. Talk to the customers and find out what is the practical application of the project life cycle here. So let's finally talk about the elephant in the room. 0.8.
Yep.
0.8, the maintenance factor. Why do we still use it?
That default number, everybody uses 0.8. It's habit.
Yep, there's a dependence. There's because everybody else does.
Yes. The tender might say so.
Yep. Acceptance, discrimination. So some people use it because they think they may be discriminated against if they use another maintenance factor.
They also think they're complying to some kind of regulation.
And there is no regulation that is stating that you should use 0.8.
There's no standards. It's down to each specific project and the type of equipment you're using within it.
Now, if the required lighting level in a room for a particular project is 500 lux, if you're utilising the standard 0.8 maintenance factor, 80%, then in order to maintain that light level for the given period of the project that we spoke about earlier, then you're going to need to initially light it at 625 lux for that 0.8 maintenance factor for that particular space.
There is a new document from BSI, British Standards Institution, called Maintenance Factor Determination Way of Working, and this is a technical submission. It's the UK implementation of the ISO CIE 2212 2019.
And that refers to CIE 97 2005, which determines the luminaire types, etc.
It's an update on some existing documents because we are now using predominantly LED, and all of the other maintenance factor documents were based on lamps that had a much shorter lamp life and a bigger deterioration. So it had to be updated. It's not been updated absolutely. There's still a few anomalies in there because they're just a little bit old, but it's great to have a new document.
Yep. The other part to refer to is the ZVI guide for reliable planning on LED lighting. So this is a very good document that helps you also with maintenance factors. It's talking in the same language, but it also uses a particular table reference that's available from manufacturers to be able to use as lookup data for LLMF and LSF data.
And then you've also got the Society of Light and Lighting handbook, which details all of these calculations.
Yep.
And also we do have the TRILUX lighting practice, which is free to download from our website, which is a great explanation of everything to do with lighting, all lighting technology.
Absolutely. So the four elements of maintenance factor, where do we find the information? So the lamp lumen maintenance factor, this is determined by the luminaire manufacturer in conjunction with the environmental conditions in which the luminaire is placed in. So some of that information comes from the project, but then you take that project information and you apply it with the information that's from the luminaire manufacturer to get your lamp lumen maintenance factor. The next one is lamp survival factor. So again, this is determined by data from the luminaire manufacturer as well as the environmental conditions that you've got. Third one, luminaire maintenance factor. So this is determined from the luminaire selection, so the type of luminaire. So is it a direct luminaire, is it a downlight, is it a suspended luminaire, is it a vaporproof, etc. The cleaning cycle that's determined by the client, and also the room type. So those two elements are going to come from the client and also from the designer. So again, this is going down the route of not making assumptions and actually finding out when the client's cleaning rota is being planned, and from the designer, what are the luminaire types that are being used in this application.
Yes, I mean the luminaire types do have some categories that have been developed for this purpose.
A through to G.
Yeah, and those are the ones that really haven't been updated yet.
Yeah, and that's the CIE 97 2005. And then finally, the room surface maintenance factor. Again, this is determined by the building design, the cleaning cycle again, and also by the room type. And is it a clean room or is it a dirty room, etc., etc. So relatively straightforward elements, but again, you're needing to gain this information from the designer and also from the client. Very briefly, we'll look at each one of these in detail. So the lamp lumen maintenance factor, you can see this table here. These should be available from any reputable luminaire manufacturer, and these are also defined in the ZVEI documentation. So here you've got the lifetime of the luminaire, and you can see the LLMF and the LSF according to the particular lifetime, but then also plot down across the top the service life, or in effect the project life of that particular luminaire. So in other words, if you are looking at a 50,000 hour luminaire, but you're only going to be using it for 10 or 15,000 hours, then it will give you a much more improved LLMF and LSF compared to if you're using it for the full lifetime of the luminaire.
And there's just a little bit in here about operating temperatures as well.
Yeah, so for example, if you take an IP66 rated luminaire and it had a 50,000 hour L80 lifetime, it could potentially have a 100,000 hour L80 lifetime if it was operated at 5 degrees. So similar scenario with the lamp survival factor. Again, you've got this table from luminaire manufacturers where you'll be able to look up, according to the luminaire data and also the project life, what the lamp survival factor is. So currently the luminaire maintenance factor is based upon old fluorescent luminaire technology that was written back in 2005, where there were no LED luminaires to be used as a principle. So this is the area that we believe needs to be updated, this element of the CIE.
We need a few more luminaire types.
Yeah, so currently they're sort of just referred to as bare battens, open top luminaires, closed top luminaires, IP rated luminaires, air handling, etc., etc. So there needs to be more definition that is more linked to the current day-to-day LED luminaires.
Yes.
And room surface maintenance factor, this is the final one on the CIE lookup tables. So this gives you a list of room dirtiness levels, so clean through to very clean through to very dirty, and then maintenance levels. So you look at the maintenance that is going to be put in by the client as to how often they're going to be cleaned. And again, this is another area where I think there's been a lot of misleading information where people have constantly put in, oh, the luminaire is going to be cleaned every 2 or 3 years. When I think the reality is nobody ever cleans a luminaire, and the old adage that, oh, well, they will clean the luminaires when they replace the lamps. Well, now these are LED luminaires, the lamps aren't being replaced, so they're not even being cleaned in the lifetime that a particular lamp may survive. So it may well be that an LED luminaire never ever gets cleaned over its complete lifetime. So you just need to be careful about that.
So let's have a look at LED life and degradation. When we talk about the life of an LED, we have to consider it from many different angles. LEDs have made vast improvements in expected lifetimes compared to other sources. There are much less movable or breakable parts, which means they're less sensitive to vibrations and shaking. But how we use them will have an impact. We normally see a curve or a line like this showing the light output when new and then showing the degradation over a period of time. However, the temperature at the junction where the LED is mounted will have a big effect on the life of the LED. Therefore, the same LED chip in different luminaires might have a different longevity. In reality, we don't want to know when the LED will fail, but when it reduces to a percentage of the original light output, and that stops the LED being useful. We sometimes talk about 70% of the original output, and this has become the accepted response. This has a big effect on maintenance factor, as Jamie has explained, but we need to understand what these numbers mean. This line shows the degradation of the LED over time. But in reality, our luminaires are made up of more than one LED. So this line is actually the average of all of the LEDs. 50% will be above the line and 50% will be below. At this point on the curve, we can say that the lumen output will be 70% of the original after 50,000 hours. 50% of the LEDs will give more than that, and 50% will give less. Therefore, it is labelled L70 B50 50,000 hours. This line shows an average degradation resulting in 80% of the output at 50,000 hours. Again, this is an average of all of the LEDs in the luminaire and is labelled as L80 B50 50,000 hours. So both luminaires can state a lifetime of 50,000 hours, but you need to look at the L number to truly understand the quality of the LEDs. These are not equal. There could also be a variation in the B label. The average of these LEDs gives L80 B50 at 50,000 hours. And this bank of LEDs is slightly better, but we could end up with the label looking very similar. This is still L80, but the number of LEDs below 80% of the original output is only 10%. Therefore, we can guarantee a more uniform degradation, and the label is L80 B10. The B50 number is at a level where the reduction in output is only 85%. The same bank of LEDs could have several different labels which potentially could be misunderstood. L80 at 50% degradation gives us 67,000 hours of life, and if we took it to the normal quoted parameters of L70 B50, we could quote a life of a massive 100,000 hours. All of these are equal and are talking about the same bank of LEDs. The problem is, which do you choose in your maintenance factor calculations? If you are using the L70 number, you should start with a maintenance factor of L70 before you start adding other variables such as cleaning. One point to remember is that the B figure is not total failure. LEDs are now very reliable, and the absolute failure rate is so low that it's not normally quoted. When doing lighting calculations, we have to look at the light that is required to do the task, and we need to make sure that this is still met after a specific period of time. The trouble with having very long lifetimes is that we have to allow for the degradation over that period of time. This means that we are overlighting on day one so that we can reach the required levels on the last day, which is the function of the maintenance factor. To understand the specific period of time is important because if an LED luminaire with a luminaire classification L85 50,000 hours is designed for an operating period of only 25,000 hours, then a value of 93 can be used as a maintenance factor for the luminous flux reduction, LLMF. It could also be specified as having an evaluation class of L93 equals 25,000 hours. Then less luminaires would be installed and energy consumption would be reduced. However, if we are looking at longer periods of time for the installation, another way of reducing the energy consumption is to use an intelligent ballast within the luminaire, which will automatically compensate for overlighting in the early years of the project. The ballast will restrict the output to the desired level by reducing the wattage and then gradually increase the wattage over the life to keep the light levels constant. This results in considerable energy savings, but also makes the installation more comfortable for the users at the start of the project. And this is something that is covered extensively in the new BSI document. In the graph for a system without CLO, the blue line shows the energy used and it remains constant throughout the life of the project. The orange line shows the light output, which reduces over time. So to make sure that we have enough luminous flux at the end of the life, we overlight at the beginning, and the orange shaded area shows the wasted energy. In the second graph, showing the system where an intelligent ballast with constant lumen output has been used, the orange line shows the light output again, but the ballast has restricted the power input to 80%. And this line remains constant because the energy used, the blue line, is gradually increased over the lifetime until it reaches 100% at 70,000 hours. And this time the green shaded area shows the energy saved by this low-cost technology. And of course, lighting controls will also achieve the same result if daylight linking is included. For instance, if you are monitoring the light output that's received on your task, and then the light levels will stay at the set amount over the life of the installation, but the wattage will increase over time.
So the next example we'll look at is basing the project life on the Luminaire life. So a luminaire that is a commercial luminaire, 50,000 hours, and we'll base this in a particular retail example. So we'll say, okay, 50,000 hours, 10 hours a day per day usage, and 312 days per annum, which basically will equate to 16 years. So this is where you'll look up and define your LLMF and your LSF based on those criteria, and you'll use the lookup table that you can see here. So actually 50,000 hours in this particular application isn't needed. So over that time frame that we've looked at for the 312 days, 16 years, then you would actually need circa 15,600 hours of life from a particular luminaire. Yeah. If you then add CLO to maintain the 1,000 lux on the key products, then obviously that makes improvements there as well. So the retail example, the client may refurb the retail space and taking the data that we've just looked at. So the maintenance factor, so if we look at the LLMF, that would equate to 0.94, an LSF of 1, LMF with a 3-year clean cycle would be 0.85, and an RMSF of a reflectance of 70-50-20 over a 5-year cleaning cycle, again, or a refurbishment cycle, sorry. That would give you a 0.94. So the total maintenance factor on this particular application would actually be 0.75. Okay. However, if you utilise the tool that we explained earlier, which gives you the CLO value and what impacts constant lumen output has on the maintenance factor, that would then give you, and I hate this bit, it gives you a maintenance factor of 0.8. But we can see we've actually worked this out correctly. So with that, you can actually use 5% less luminaires in that particular design and that application through calculating the maintenance factors correctly for the application with the right refurbishment cycle and the cleaning cycle and all the other elements, and adding constant lumen output gives you that maintenance factor and that particular saving.
And this is the benefit of working it out properly.
Exactly. So now we come on to probably one of the biggest areas to challenge the 0.8 is how to put out tenders.
Yeah.
And this is theoretically, by putting 0.8 on a tender, you may think that you're introducing a level playing field. But actually it's not the case because you can't take into account some luminaires that may perform in better thermal environments or may have certain technologies that other luminaires may not. So when it comes to the tender process, your end client maybe not be getting the best option for that particular tender.
If a luminaire has been designed specifically for a situation, and it's taken into consideration all of the different factors that are needed for that application, your maintenance factor is probably going to be higher than 0.8. So you're actually losing some of those benefits. Or
it can go the other way as well. So it depends on the application. Yeah. So for example, we've already seen with the 4 factors, there are different areas where the information comes from. So with the LMF and the RSMF, in the project detail of the tender, with the temperature range and the project life that can be determined by the client and consultation with the consultant, you can actually put that information in the tender. That then allows the tenderees to then utilise their own data that's specific to their luminaires on the LLMF and the LSF to determine what the maintenance factor is in total for their submission of the scheme.
Giving you the option to put in a few variables.
Exactly. So for example, the designer and the client would put forward the LMF and the RSMF. They would also put forward data saying it's at 5 degrees for this particular application, what the project life is, so obviously going back to, is it based on the lease length or the building life or the luminaire life, or what the project life is based upon, and also the cleaning regime data. If you put that element of data into the tender package, then it then leaves the flexibility for the luminaire manufacturer or the electrical contractor or installers to then put forward a scheme that takes that data in conjunction with the luminaire data that is specifically correct for the luminaire and put forward a very accurate tender submission.
Yeah. Right, we'd just like to finish with a few tips, summarising what we've been talking about and hopefully trying to put it into context.
Yes.
So if we look at an office environment, some of the things you can do is incorporate daylight controls, incorporate constant lumen output, and by doing these you can then affect your maintenance factor, which will reduce the quantity of luminaires you actually put in the space. A lot of offices are very clean now.
No more smoking in offices anymore.
No, that's not allowed anymore. And by correctly specifying the cleaning regime, you can end up with an accurate calculation, put in the right amount of light from day one, which is going to last you for the lifetime of your building.
And do question, going back to the lease, because so many office conditions now are leased, and that will have a huge impact on the project life, and therefore getting the correct maintenance factor and making sure you're not overlighting it.
Tip 2.
Tip 2, industry. So most luminaires are generally rated for higher temperatures, e.g. maybe looking at 45 degrees for a particular luminaire, and it may be working in 25 degree ambient operating conditions. So maybe it's a logistics hall or something of that ilk. You may be using a luminaire that might be used for industry that can cope with higher temperatures, but you're actually using it in something like a logistics hall,
which is colder.
Temperature's a lot lower, so therefore you're going to improve your lamp lumen maintenance factor, your LLMF, and also IP rated luminaires also have a better LMF because of the impact on the cleaning as well.
The dust can't get in
Exactly. Tip 3, sort of touched on this slightly, logistics. So again, most luminaires can operate at the higher operating temperatures, or you're using luminaires that operate at different operating temperatures. Again, daylight controls. I went to one recently. It had no lighting installed in a particular logistics hall. It was like a Cat A fit out, and just with the daylight panels, they were getting 400 lux in there. So again, it's making sure that the daylight control is put in place, the constant lumen output is there, and all of those you can use the correct maintenance factor to not overlight the space, keep the environmental impact down, and improve that LMF and that RSMF.
Tip 4. Retails, shops, usually a much shorter project life because they want to have their maintenance and refurbishments a lot more often. So take this consideration into your calculation of the maintenance factor, therefore a higher maintenance factor, less overlighting on day one. Again, constant lumen output will really help in this situation as well. Always improving the maintenance factor. Right, let's look into the future. Jamie, can BIM be the answer?
To quote Martin Luther King, I have a dream. So, if the BIM model can contain all the relevant info for the project, then theoretically it can also have all the right data and information to make the decision about the LMF, the luminaire maintenance factor, and the RSMF. The luminaire files that you then put into it with the Revit data could also contain the relevant information in regards to the LLMF and also the LSF data. So theoretically, you've got everything in there, including the project life and how you operate the building and what the cleaning cycle is. Everything is there potentially within the BIM model to be able to calculate a correct maintenance factor. So imagine if you could press a button and you could literally calculate the accurate, correct maintenance factor for that building.
And this is actually easy. We're only talking about a simple calculation. Those variables can be determined by the BIM model,
and also by the owner later on. So should the client change the building regime, the operation or the cleaning cycle, then the BIM lifecycle model can also change the maintenance factor within the calculation ongoing to then also see what the life predictions are, the life predictions on the luminaire, but also life predictions on what the energy consumption may be. And they could do this either before they make the change or even if they're considering making changes.
And also if there's a change to the BIM model, which is going to have a detrimental effect, this might mean you might want to improve your cleaning regimes.
Or maybe not even go ahead with that particular refurbishment that they're planning because of the impact that it may have on the energy consumption through the net effects on the maintenance factor.
So the information that goes into the BIM is the key. we are only talking about a simple calculation.
Exactly.
That information is what really drives all of this.
Yep.
And why not let BIM
I think it would be
do that?
fantastic if we could get this underway.
This is the future.
Yep, absolutely. So finally, true maintenance factor. There is no better way than actually calculating what the true maintenance factor is. We've obviously covered a lot of topics here. It's been a hard subject matter to cover.
It's not an easy,
No, it's not.
exciting subject.
But it's about not overlighting the scheme and not underlighting it. It's about customer expectations and making sure that what the customer gets is what they are expecting, and also what they've paid consultants and designers to deliver, as well as all the electrical contractors and the luminaire suppliers, etc., etc.
This is bespoke lighting for your project with all the correct information.
Yeah, it's not difficult. Maximises on the energy efficiency on the project. It's ensuring that we get a better understanding of the project. So it's just asking a few simple questions of the client to determine how the building is going to be used to enable these decisions to be made and create a much better understanding of the project, and ultimately save them money and save energy. And then finally, what it also does, it ensures that the client's needs are met from day one. So they're not overlighting the space and they're only paying for what they need.
So thank you for joining us on this challenging topic.
Yes, thank you for sticking with us. Please do try not to use 0.8 unless you've actually calculated
Yep.
to be 0.8. It's been a difficult topic. I think we've got there. If there's any questions, please also do contact the TRILUX Academy.
Yes, academy@trilux.com.
And from myself, Jamie Yates,
And myself, Helen Loons. Goodbye.
thank you very much. Goodbye.